eigrp is second routing protocol, guys, which we are going to discuss. Till now we have discussed static routing and RIP. Today we are going to start eigrp. First of all, tell me, eigrp stand for what? eigrp stand for what?
Enhance.
Enhance interior gateway routing protocol.
Very good. It is enhanced interior gateway routing protocol. Right? It is an IGP protocol or EGP protocol. Nowadays it
By
is open
default,
standard. Yes,
uh, it is basically
IGP,
by
sir.
default it is interior gateway.
interior gateway protocol. Now it is open standard and it is, we called it, eigrp is an advanced distance vector routing protocol also, or we can say it is an hybrid routing protocol. Hybrid routing protocol, because it have some property of distance vector and some property of link state protocol. So that's why we call this protocol as hybrid protocol also. It is an IGP protocol, definitely yes. What is the meaning of IGP?
Interior gateway protocol.
Yes, what is the meaning of interior gateway protocol?
The protocol which is used inside the organization.
It will work within, yes.
Same autonomous system.
Yes.
Under single infrastructure.
Mm, okay. So IGP means it will work, eigrp will work within AS. Between AS, this protocol will not work. Let's say we have two router, both are directly connected. On router 1 we are running AS10 and router 2 we are running AS20. So eigrp neighborship will not come up. Right? After that, the most important thing is metric. Guys, what is metric in case of distance vector routing protocol like RIP?
Hop count in
Hop count.
case of.
But here metric is equal to k values. It depends on k values. How many k values we have?
Five.
K1,
5.
5 k value. K1 is
Bandwidth.
bandwidth. K2 is
Load.
delay,
load. K3 is
MTU sir. Or
K3 is delay.
okay.
Then K4. K4 is
I guess it should
MTU.
be
reliability.
MTU. Okay.
And K5. K5 is MTU. As you know, MTU stands for maximum transfer unit. So eigrp uses these k value to calculate metric, but by default it is using only two k value, K1 and K3. K1 and K3 by default. Otherwise it can use all k values to calculate metric. And formula to calculate metric is 10 power 7. 10 power 7 upon divided by list metric. Here we have list bandwidth. Now what do you mean by list bandwidth? It will compare the bandwidth which is coming in update and bandwidth of my link. Bandwidth of my link. After that plus plus total delay upon divided by 10 and whole multiply by 256.
6.
This is formula to calculate matrix. Is it clear?
Okay.
Now let's say I have one router over here, router 1, and I have one more router, it's a router 2, and here I have one switch. This is my R1, this is my R2. Okay, this is, let's say, fast Ethernet link F0/0, F0/0, and this is also fast Ethernet link F0/1. Here I am running one network, let's say 192.168.10.0/24. Done. Guys, command to enable eigrp is very simple. Router eigrp and then ES number 10. After that you will run network command. Network 192.168.10.0 and then wildcard mask. Then you will define wildcard mask. What is wildcard mask? Wildcard mask is opposite of subnet mask, which is used to match the prefixes, the bits. Okay, after running this command, what will happen? F0/1 will join a multicast group. Which multicast group?
224.0.0.10.
It will join that multicast group 224.0.0.10, this multicast group. And router 1 will calculate matrix for this network 192.168.10.0. So can anyone tell me what will be the matrix on router number 1 for this network? Matrix will be what, guys? 10 raised to power 7, 10 power 7
7 by 100.
by 100,
100.
not in Mbps, bandwidth in kbps.
Okay.
List bandwidth in kbps. So here we will have 3 more
100
0, right? Plus total delay. So delay will be, what is delay of fast Ethernet link? Can anyone tell me?
19.
No. Delay of fast Ethernet link. You guys have not checked ever. Delay of fast Ethernet link is 1000. 1000 divided by 10. Divided by 10 and whole multiply by 256. Can anyone calculate the value? Delay of serial link is 20,000. Delay of Ethernet link is 10,000. You can write down somewhere. And delay of fast Ethernet link is 1000. Delay of giga Ethernet link is 100. And delay of 10 giga Ethernet is 10. means delay is inversely proportional to bandwidth. Now here I have one router, here I have one switch, this is connected like this. Here we are running network 192.168.10.0/24. So my question is, what will be the metric on router number 1 for this network? Definitely router will calculate metric. When I will enable eigrp on this router, router will calculate metric for this network. So what will be the metric? And see, if you want to see the bandwidth and delay, so IP interface F0/0, or directly I think I need to run show interface fast ethernet 0/. Bandwidth is 100 Mbps
Yes.
and delay is 100 ucosecond. But we are discussing, here the formula total delay upon 10. So delay is in milliseconds. So here you need to multiply it by 10. Okay. Now what I am going to do, I am going to configure the IP address over here. Interface F0/0 no shut and IP address 192.168.10.1 255.255.255.0 and router eigrp AS number, let's say I'm using 10, and network 192.168.10.0, wildcard mask 0.0.255. See, here metric will become 10 to the power 7 upon 10 to the power 6 plus total delay 1000 upon 10 and whole multiply by 256. Here we have 10, oh sorry, we will have 10 to the power 5, not 6. 10 to the power 7 upon 10 to the power 5 plus total delay 1000 upon 10 and whole multiply by 256. So here you will get value 100, here you will get value 100 multiply by 256. So 200 multiply by 256. What will be the value, guys? Can anyone calculate it? Or let me calculate. $200 multiply by 256. This is the value. This value I am getting over here. And router 1 is calculating same value or not. Let me do one more thing over here. Once again, delay should be 100 over here, not 200. 1000. 100. So here value will be only 10. So it will be 110 multiplied by 256. So 110 multiplied by 256, what value I will get? 110 multiplied by 256. This value 28160. Yeah, this one is correct. And so IP eigrp topology. Here you can see the metric. Done. Okay, now question is, when here we have one more router, let's say router 2. Between router 1 and router 2, I am using a network. Let's say 2L network I am using between router 1 and router 2. So let me configure the IP. Interface F1/0 no shut and IP address is 2L.1.1.1 255.255.255.0. I'm going to enable eigrp on this interface also. So router eigrp 10 and network 12.1.1.0.0.255. Let me take you to router 2. On router 2 also I am going to configure eigrp. Router eigrp is number 10, network 12.1.1.2 255.255.255.0 exit. Router eigrp is number 10, network 12.1.1.0.0.255. Done. Now router 1 will advertise 192.168.10.0 network to router number 2. Now can anyone tell me what will be the metric on router number 2, guys? What will be the metric? When router 1 will advertise 192 prefix to router 2, what will be the metric? See, in the update message, router will send some information, like there will be network information 192.168.10.0, subnet mask will be there. After that, bandwidth will be there. Bandwidth
So
of receiving interface, it will be what? And there will be delay will be 100. Now how router 2 will calculate metric? It will share this information to router 2. Now how router 2 will calculate metric? Again router is going to use same formula, 10 raised to power 7 upon least bandwidth. The bandwidth which is coming in update is 1 lakh kbps, and bandwidth of my link is also 1 lakh kbps. So both are same, so it will use 10 to the power 5. Then total delay which is coming in update is 100, and delay of my interface is also 100 upon 10 and whole multiply by 256. So here again we will get 100 plus 20 whole multiply by 256. So 120 multiply by 256. This value you will get as a metric on router number 2. One 20 multiply by 256. 30720. Let me show you on router 2. So IP route eigrp. So IP eigrp neighbor. There is no neighborship. So IP interface brief. There is no IP address. Interface F0/0. No set. IP address is 12.1.1.2 255.255.255.0. Exit. Router. We are running routing protocol or not? Do so. IP protocol. We are running the routing protocol eigrp. So IP eigrp neighbor. This is neighbor table. In neighbor table you can see there is one neighbor. 12.1.1.1 is the neighbor router. On which interface? On F0/0 interface. And we will discuss about this timer. Hello time, update time, SRTT time, RTO time, queue count, and sequence number. So IP route. See, it have learned this network from eigrp, and metric is 30720. Now if router 2 is connected with one more router, let's say R3. So R3 will calculate what metric? Tell me guys, R3 will calculate what metric for 192.168.10.0 network? Please calculate it. Use the formula.
It's 33280.
Hmm.
33280.
33280. Okay.
Three three two eight zero.
Is metric calculation clear to everyone? Or if anyone have doubt in metric calculation, let me know. Now only. If anyone have doubt in metric calculation, please let me know.
So 10 to the power is fixed, or we can change it according to a requirement.
10 to the power 7. This is
Yes,
fixed.
sir.
This is fixed.
Okay, sir.
Now,
And at the end of the when we multiply with 256, it means 256 hops.
exactly. Now I am connecting one link between router 1 and router 3. So can you tell me what will be the metric on this link, brother? Yes. Now router 3 have two paths to reach 192.168.10.0. So router will use which one? It will compare what metric only. So what will be the metric on serial link? Interface S2/0, no shutdown, and IP address is 13.1.1.1.255.255.255.0. Exit router eigrp10. I'm going to advertise this interface also in eigrp. Then to router 3, interface S2/0, no shut, IP address is 13.1.1.3, let's say 255.255.255.0. Exit router eigrp 10 and network 13.1.1.0 0.0.255. So IP route eigrp. It have installed this network via which router? Via router number 2. Yes or no? So IP eigrp topology. Here are you able to see two paths for this network? Yes. On fast Ethernet link, metric is 33280, and on serial link metric is this one. So router is calculating least metric on fast Ethernet 0/0. So that's why it have installed this path in the routing table. Done. On serial link also metric calculation will be same. You can find the bandwidth of a serial link, delay of serial link. Okay. So router 3 have two path, but it have installed only one path in their routing table. So IP route eigrp, because it is getting least metric via router number 2. Done. Till here is it okay, guys? Can anyone tell me why we are using K1 and K3, means bandwidth and delay only, to calculate metric by default? Can anyone tell me the reason, the logical reason? Because these two components are fixed and rest components are variable, like K2. K2 is what?
Load.
Load. So load is not fixed. Load can be vary.
Variable.
Yes. If there are more traffic, that means more load. Less traffic means less load. So that's why we are not using load components for the metric calculation. Otherwise my metric will also vary. So by default we are using those components which are fixed, like reliability. Reliability is also variable. Okay. Now on any router I am going to run command show IP protocol. As you know, show IP protocol is the command, verification command to check the routing protocols. Show IP protocol. Here we are able to see the routing protocol is eigrp number 10. We don't have any filtering for incoming traffic, for outgoing traffic. After that, metric width K1 value is what? 1, and K3 is 1. Rest are 0. That means we are using K1 and K3 only to calculate metric. Hold on time is, this is different timer. Okay. We have router ID concept as well in eigrp, but we will discuss router ID in OSPF. This is nothing but the identification ID of a router in eigrp domain. Okay. After that, distance you can say for internal it's 90 and for external 170. Maximum path that eigrp can install in the routing table is 4, and the maximum hop count that eigrp can support is 100. By default variance value is 1. We will discuss the variance value also later. Auto summarization is disabled. By default automatic summarization is
ಜೋರ
enabled
ಮುಖದ
in
ಮೋದ
case
ಒಗಸಲ
of
ಪಾಪ
RIM.
ಆಗದು ಈ ಒಗರೊಂಬ
But
ತಿನ್ನ
here,
ಉನದು ಕುದನಕ್ಕೆ ಏನಾವುದು ಒಗರು ನೋವಾಗುತ್ತಾನ ಮತ್ತೆ ಪಾಪ ಆಗದು ಊಟ್ಲ
but here in eigrp by default auto summarization is disabled. Okay, and then we are performing routing for these 3 network. After that, neighbor gateway 13.3 and 12.2, both are internal, so distance is, you can see, 90. Done. For external we will discuss later. Okay guys, so till now metric calculation, hope metric calculation is clear to all. Yes or no?
Yes.
It uses multicast address 224.0.0.10. If you want to capture the link, if you will capture the link, see the hello message. Router 1 is sending the hello message. Source IP is 12.1.1.1 and destination IP is 224.0.0.10. Inside the hello message, we don't have opcode which identify the types of message, then checksum value, flag, sequence number, and we have some parameter over here. In parameter you can see K1 is 1, K3 is 1, rest are 0. That means router 1 is telling to router 2, I am using K1 and K3. If you are also using same value, same K value, then only we can become neighbor. Let's say router 2 is using K1 and K2, K3. Then router 1 and router 2 cannot form neighborship. and hold on time is 15 seconds, and hello time is 5 seconds. Done. So means when we are enabling eigrp on any interface, it starts sending hello message, and when it will receive hello message on the interface, it will check some parameter. If that parameter or those parameter will match, then only toRouter will become neighbor. So let's say router 1, router 2, R1 and R2. Here let's say IP address is 12.1, and here let's say IP address is 12.2. So once you will enable eigrp, once you will run command router eigrp AS number 10 and network 12.1.1.0. What router 1 will do? Router 1 will send one hello message. Inside the hello message, router will share some information like AS number, AS number and K values. K values. If AS number and K values both will match, then only these two router will become neighbor. Now I have not configured eigrp on router number 2. I have not configured eigrp on router number 2. So router 2 will discard this hello message. Yes or no? Now question is, at which layer router 2 will discard it? At which layer it will discard it, guys?
At layer 2.
How? Definitely at layer 2, but how? By checking the destination MAC address. Destination MAC address will be the multicast MAC address, and this interface is not the member of that multicast group. That's why router 2 will discard it. But let's say here also I have run command router eigrp AS number 10 and network 12.1.1.0. So router 2 will also send one hello message to router 1. Router 2 will also share their AS number, and K values. K values. Hello message. This is how two router form neighborship in eigrp. AS number in the hello message will be what here? 10, and here also what AS number will be 10. But let's say here we have configured AS number 20. So it will share hello message with AS number 20, and router 1 will discard this hello message. Actually eigrp will discard the hello message on router number 1. Let's say I have configured the same AS number, so it will send AS number 10. So both router will become what? Neighbor here, because both have exchanged the hello message and parameter have matched. So both router will become neighbor. Neighbor. After becoming neighbor, router will send what? It will send one null update message. Router 1 will send one null update message. May I know the reason of sending null update message? Why router 1 is sending null update message? Router 2 will also share null update message. null update. Why guys routers are sending null update? Yes, Rohit? To check bi-directional connectivity. Guys, eigrp is a reliable protocol. What I am saying, eigrp is an reliable protocol. eigrp is reliable protocol. That means all reliable protocol will have one acknowledgement, yes or no? But not all message of eigrp is reliable. Like hello message is not a reliable message, but update message is reliable message. Query message is reliable message. We have query as well. And reply message is also reliable message. So these three messages are reliable message. Whenever router will send update message, query message and reply message, router will expect the acknowledgement. Router will expect acknowledgement. Getting my point? These three messages are reliable. So that's why router are sending the null update message to check that I am getting acknowledgement from router 2 or not. And router 2 is also sending the null update message to router 1 that I am getting acknowledgement or not. This is bidirectional connectivity. Okay. Okay, so when router 1 will receive the acknowledgement from router 2, it will send the actual update message. Then it will send actual update message, and router 2 will also send actual update message. In actual update message, what router will send? Routing table. Let's say router 1, router 2 have one network 10.1.1.0/24 and router 1 have one network 20.1.1.0/24. So router 1 will send which network? 20.1.1.0/24 through main update message, and router 2 will send 10.1.1.0/24 network through the update message. And both router will send acknowledgement after receiving update message. Done? Hello? Is it clear?
Sir, after routing table update, there will be the acknowledge of null update only.
Null update message is also reliable message, na brother? So it will send acknowledgement. After each and every update message, router will send acknowledgement. Okay. Can anyone tell me when router 1 will generate hello message at layer 3? Actually, hello message will be generated by eigrp. After that, eigrp will hand over this hello packet to IP protocol. IP protocol will do what? IP protocol will add source IP and destination IP. So here source IP will be the IP address of exit interface 12.1.1.1 and destination IP will be multicast 224.0.224.0.0.10, and there will be one protocol field. In protocol field, what will be the value?
88.
88. Okay. After that, it will hand over to layer 2. Layer 2 will add Ethernet header. In Ethernet header, it will add source MAC, destination MAC. Destination MAC will be multicast, and in type field value type value will be the type code of IPv4. Okay. If you want to see these things, what I can do here, I am going to close this capturing, and I'm going to delete router 3. Here I am going to say stop capturing. Okay, I'm going to remove the eigrp configuration from here first. No router eigrp is number 10. Then from router number 2 also I am going to say no router eigrp s number 10. Do ping 12.1.1.1. Yes, I am able to ping 12.1. Done. Now I am going to configure eigrp. Before that I am going to capture the link. And on router number 1 I am going to say router eigrp 10 network 192.168.10.0.0.255 and network 12.1.1.0.0.0.255. Done. See, router 1 is sending hello message only. Where is my capturing? Router 1 is sending only hello message. Until and unless router will not receive any hello message on F0/0 or F1/0, it will not send null update message. So I am going to configure eigrp on router 2. Once I will enable eigrp on router 2, router 1 will receive hello message. Router eigrp 10 network 12.1.1.0.0.255. Done. This interface router 2 will also start sending hello message. Okay, and see the all. Let me stop the capturing now. See, earlier router 1 was sending the hello message. This is the first hello message of router 2. 12.1.1.2 is sending this hello message on this multicast address. After that, this is the hello message of router 1. Then router 1 have sent what? Update message. Are you able to see the update message? If I will open this update message, see, in this update message we don't have any network information. Are you able to see any network information? There is only ES number and we have some flag. We don't have any prefix. Okay, and opcode value is 1. Opcode value 1 means update message. Update message have opcode value 1 and hello message have opcode value what? 5. Okay, so router 1 have sent one update message, null update message, and this message is unicast or multicast. This is a unicast. As I told you, it is used to check bidirectional connectivity. Both router have sent the update message on unicast address. Yes or no? Router 2 have also sent one null update message on unicast address, and router 2 have also sent one update message on unicast address. Yes?
Yes, sir.
Yes, guys. After that, again we have same message, right? This is GNS3, so that's why you are able to see two null update message, but in real devices in real time you will see only one message, because router have sent the update message but router 2 have not sent the acknowledgement, so that's why router 1 is sending again. And in the same way router 2 have also sent but it have not received any acknowledgement, so it is also sending again. Then you can see the acknowledgement. Router 2 have sent one acknowledgement to router 1 and router 1 have also sent one acknowledgement to router 2. And once router 2 have received the acknowledgement, have sent the acknowledgement message to router 2, to router 1. This is the acknowledgement message. I am talking about this message. See, who is sending? Router 2 to router 1. Once router 2 have received this acknowledgement message, router 1 have sent actual update message. This is actual update message. Okay, if you will open this actual update message, so in this update message actually router is sending network information. Which network information? 192.168.10.0. okay, and here we have metric component. C, router is sending what? Bandwidth plus delay as well. This is the network, right? This is the router ID of router 1 and it is sending the delay and bandwidth in the update. When router will receive this update, it will compare delay and bandwidth from this update. Getting my point? Okay. And this is actual update message of router 2. Router 2 have sent to router 1. And you can see after update message acknowledgement is there. Done. Means router 1 is sending this network with metric components, all metric components. And router will compare to their receiving interface bandwidth and the bandwidth which is coming in update. The receiving interface delay plus the delay which is coming in update. Here on router number 2, so IP route eigrp. You can see this router have now this network and metric is this one. And if I will change the bandwidth of link interface f0/0, let's say bandwidth 10. Now it will compare bandwidth which is coming in update and bandwidth of my link. So bandwidth of my link is lower, least. So it will use the least bandwidth. So IP route eigrp. Now you can see metric is different. And when router 2 will share this network information to their neighbor, let's say router 2 is connected with router 3. So router 2 will share least metric till here in the update message. Getting my point, guys? Let's say here I have one more router. So router 1 have advertised 192.168.10.0/24 network to R2 with delay and metric. With metric is, let's say what, 4, 5. This one, and let's say delay is 100. So when router 2 will advertise it to router number 3, this time metric will be what? Bandwidth will be what? So interface f0/0. This will be the bandwidth. Getting my point? So here it will share least bandwidth 10. And delay will be what? Delay which is coming in update is 100 and delay of this interface is also 100. So delay will be 200, total 200. When router 3 will receive 192.168.10.0, it will compare to their interface. And which one is least metric? Least bandwidth. Bandwidth which is coming in update, yes or no? Okay. Is it clear to everyone? Tell me.
So from router 1 to router 3, the bandwidth is 10 Mbps.
Yes. Always keep in mind that router will advertise least bandwidth and total delay in the update message.
Sir, so least, say for example, for R2, you told it will send the
Please
least
speak loudly.
Sir, for R2, as you spoke that it will send an update with least bandwidth of 10, correct?
Yes.
But 10 is set on router 2's F00.
Yeah.
So for that particular segment, it will send it to other segment.
Yes.
Like for every now and then, like for one hop, it will send that information to other segment. Is it
Yes.
is it what like it? So this calculation will continue, correct?
Exactly. When router 3 will advertise to router 4, let's say, it will advertise what bandwidth? 10. Because till router 3, least bandwidth is 10.
So
Okay, guys.
Okay, okay.
bottleneck like scenario here.
Mhm. Tell me.
So it is a bottleneck neck like scenario, sir. Can we say?
Yes, yes, exactly. Is it clear to all?
So here we are not taking the bandwidth of the interface.
We are taking the bandwidth of receiving interface.
Receiving interface here we are taking. Okay, okay.
Yes. Okay.
Sir, in update message they share the topology table or like a routing table.
In update message, it will send not routing table, brother. Prefixes of routing table.
Okay, prefixes of routing table.
Yes. Prefixes of routing table except the prefix which is running on the same segment from where router is sending update message. Like when router send update message to router 2, it will not include 12 network. When router 2 will send update message to router 3, it will not include 23 network. Okay. Can I move then?
Sir, in hello message they share router ID or not?
In hello message.
Uh,
Yeah, router is sending
nee.
router ID in hello message as well.
Okay, okay.
eigrp works on which algorithm?
Dual
Dual.
dual algo
Dual algorithm. Dual stand for diffusing
or
update
diffusing.
algorithm. And we have some terminology of dual algorithm like FTRD successor, feasible successor. You know this? These are guys concept of eigrp, like eigrp works on dual algorithm. Dual stand for diffusing update algorithm. And we have some terminology of dual. First is FD, second is RD, third is successor, fourth is feasible, successor. FD means feasible distance. FD is nothing but feasible distance. Guys, this is total distance from source to destination. Total distance between source and destination. Total distance from source to destination. RD stand for
Reported distance.
reported distance. And this is also total distance from neighbor
From the
to
name, yeah.
destination. And successor is nothing but your best path. And feasible successor is nothing but your backup path. Backup path. FD, total distance from source to destination. RD, total distance from neighbor to destination. Successor means best path, feasible successor means backup path. Now I am going to design one topology here. R1, R2, R3 and R4. R1, R2, R3 and R4. Here I have one network. Behind router 4, I have one network. Let's say this is the interface of router 4, and on this interface, let's say this is F0/0. Here I am running one network 192.168.10.0. Let's say metric on this link on F0/0 is 5. Metric on this link is 5. Metric of this link is, let's say, 10. Metric of this link is, let's say, 15. Metric of this link is, let's say, 15, and metric of this link is, let's say, 2. Getting my point? Now router 1 will receive 192.168.10.0 network from two sides, from router 2 also and from router 3 also. Yes or no? /24 here also and /24 here also. Guys, here what will be the metric? What will be the FD? FD equals
30.
30. Very good. What will be the RD?
22.
15.
15. Here what will be the FD?
22.
22.
And what will be the RD?
20.
20. So always keep in mind, router install only successor path in their routing table, and eigrp router installs successor and feasible successor in topology table. Successor and feasible successor in topology table and successor in routing table. So according to you, tell me which path is successor path, where router is calculating list metric via router number 3. Yes. So this path will become what? Successor. This path will become successor. Now question is, will alternate path become feasible successor or not? For that we have one feasibility condition. Because we have one more path, definitely in the topology table. If I will talk about the topology table of router 1, in the topology table, router will install this network 192.168.10.0/24 metric 22, and this is successor path reachable via R3. Right? This is the topology table of router 1. Will router 3 install alternate path in topology table?
Yes.
For that we have one feasibility condition. What is feasibility condition, guys?
RD should be less than FD.
FD of successor or feasible successor?
FD of successor.
FD of successor must be
No, sir. RD. RD.
RD.
should be less than FD of the feasible successor.
FD of feasible successor of feasible successor. RD of successor
So less than
RD of successor should be less than
FD of feasible successor.
FD of feasible successor. So in my scenario, RD of successor is
20.
20. It should be lesser than FD of feasible successor. So feasible successor FD is what? 30. No. Yes or no? Means FD of feasible successor is greater than RD of successor. That means this path can become feasible successor. This path can become feasible successor. So router will install how many paths in topology table? Guys, this feasibility condition is not correct. Feasibility condition is RD of feasible successor must be greater than FD of successor. So here you can see RD of feasible successor is 15, should be
Less than 22.
yes 20. FD of feasible successor, that is 22. That means my upper path will become
Backup
feasible
path.
successor. So router will install both paths in routing table 192.168.10.0/24. FD is 30 and reachable via R2. Done. This is topology table of router 1. Now in the routing table, router will install how many paths? Only one path, successor path. Routing table. It will install 192.168.10.0. FD is metric is 22 and reachable via R3. Done. So actually eigrp routers first build topology table. After that it will run dual algorithm on topology table and it will calculate the best path and it will install best path in routing table. Done. Any confusion till here?
So, sir, dual will work on topology table for injecting
For selecting
the
the best path.
for selecting the okay.
Sometime interviewers, asking easy question as well, like what is the use of hello message in OSPF in eigrp. So here, what is the use of hello message? Can anyone explain?
To build the neighborship.
Yes, to discover the neighbor and keep alive. What is the use of update message?
To share the information,
Routing
information.
information with neighbor.
That is also on triggered basis.
Yeah, that is secondary things, by the way. 1 minute. And what is neighborship parameter? Neighborship parameter is only AS value must match, and K value must match. After that, if you have configured the authentication, so authentication should match. Otherwise, as you know, authentication is optional. So only two requirement is there to form eigrp neighborship: AS number and K values. Done, guys. Update message is used to share network information of routing table to neighbor router. And update message is reliable message, always keep in mind. On serial link, it will be always unicast. On Ethernet link, it can be unicast, it can be multicast. Null update message will be unicast, and the main update message will be multicast. But on serial link, it will be always unicast. If I will talk about the content of update message, so as you know, update message carry version information, opcode information, sequence number, AS number, prefix means network, after that bandwidth, load, delay, reliability, MTU. These things will be carried by update message. Okay, and when we are running command here, so IP eigrp neighbor, so IP eigrp neighbor. Here, are you able to see this timer? SRTT timer. So what is this timer, guys? Okay, this one is fine, hold on timer. This is the update timer till when this router have, you know, this neighbor uptime, right? So around 25 second hold on time. For how long time it is going to hold this neighbor? After that we have SRTT time. This SRTT time is what? SRTT stands for smooth round trip time. The amount of time in millisecond, what I am saying, the amount of time in millisecond that a eigrp router will wait for acknowledgement. So if router 1 have send one update message to router 2, it will wait for acknowledgement till SRTT time. And how router have calculate SRTT time? With null update message. Whatever time router will take to give acknowledgement of null update message, that time will become what? SRTT time. Means generally I can get acknowledgement message within this time.
So it is not fixed.
No, it is not fixed. Okay. So this is also one interview question, by the way, SRTT time. So amount of time in millisecond that eigrp router will wait for acknowledgement. How many messages are reliable, you already know. So if any router will not send acknowledgement to eigrp router, then what eigrp router will do?
So resend.
Let's say router 1 have sent one update message to their neighbor. It is waiting for SRTT time, and within SRTT time it have not received the acknowledgement.
Then it will again send the update.
It will again it will not receive the acknowledgement then.
Then maybe it's
Okay, so that is good. But see, first of all, it will send the multicast update message, and if it will not get acknowledgement, then the next message will be unicast. Getting my point? Next message that router will send again will be unicast message. router will start sending unicast message. Again R1 will wait for
56 seconds.
acknowledgement. This time it will wait for RTO time of the acknowledgement. One router will send the update message. It have not received the acknowledgement within SRTT time. Then router will send unicast update message and it will wait for RTO time. Okay.
But if again can't receive the
Okay.
acknowledgement.
Let's say if again R1 not receive acknowledgement within RTO time, then router will send unicast update message again with same sequence number, and it will send 16 time unicast message. After that, router will break the neighborship with that router. RTO, with the name RTO stand for retransmission packet back.
336 is the seconds in second.
Yes, it is in second. This timer is in millisecond, brother. This is millisecond, not second.
So after every 3 millisecond, it will send the one update message.
Yes. This is nothing but the amount of time that eigrp wait for the retransmission.
So the packet is going to be a multicast when it is using SRT, and the packet is going to be unicast when it is using RTO timer.
Exactly.
So only one time it will send the multicast first time.
First message, yes. After that it will send how many unicast messages? So 16 unicast messages to the neighbor. And if after sending the 16 unicast message router will not receive the acknowledgement, directly router is going to break the neighborship with that neighbor.
What
Okay.
if more than one neighbor not sending back the acknowledgement?
It will break the neighborship with all neighbor.
No, I'm talking about the first time. First time it will sending the update message on multicast to
Okay.
their neighbors. And what
Yeah.
if more than one neighbor?
Let's say if router have not received acknowledgement from two neighbor. Okay. So it will send unicast update message to those two neighbor, and it will wait for acknowledgement till RTO time. If within RTO time it will not receive the acknowledgement, it will retransmit the same unicast update message with same sequence number to both neighbor. And after sending the 16 unicast message, it will break the neighborship with both neighbor.
So here the router is more than one, so it should not be a multicast.
No. It will send unicast. It will generate two unicast message, one for one neighbor and other for another packet, second packet for another neighbor.
Okay.
I am saying unicast. Whenever router will not receive acknowledgement after sending the multicast update message, it will start sending unicast update message.
So why always the packet is unicast on serial link?
So the reason is very simple, because through serial link is point to point link, right? We have connected directly two device together. So there is no logic of sending multicast traffic on serial link. Yes or no? Because let's say two devices are directly
But
connected with
there
on
is no MAC address associated with serial link. Perhaps that is the
yeah,
reason.
no MAC address. Let's say R1, R2, we have one serial link. So whatever message router 1 will share on this link, that message will receive by router 2 only. Only router 2, because this is point to point link. Okay, Rohit.
Yes, sir. Yes, sir. So what's the multicast address it is used by layer 2, sir?
It will use one algorithm to calculate layer 2 address whenever layer 3 address is multicast. You have to understand multicasting for this, that how router is calculating
So is there no fixed
layer
number
2
for layer
multicast
2s?
address. On the basis of layer 3 multicast address, every time devices calculate layer 2 multicast address.
So it is a variable, it keep on changing every time.
Yes. In eigrp, destination will be always what? 224.0.0.10. So to corresponding this address, devices will have one MAC address, layer 2 MAC address. Anything else? And one more thing. See, when router have sent the unicast message and it have not received the acknowledgement. Getting my point? Whenever router have sent one unicast message and it have not received the acknowledgement, means router is waiting for the acknowledgement from neighbor. So for that neighbor, queue count will also increased by 1. Generally queue count should be 0. If queue count is 0, that means eigrp is working fine. If queue count is not 0, that means eigrp is not working fine. Router will send queue count 1, means I send one update to neighbor, and when this router will receive acknowledgement, queue count will set as 0 until and unless it will not receive the acknowledgement, queue count will be increased. Okay,
So the moment it become queue count 16, it going to break the neighborship.
exactly.
What's actually mean by the sequence number here, sir? What can you
A
brief?
sequence number is okay, we will understand sequence number later. Don't worry, whatever things we are not discussing here now, that means we will discuss that later. Okay, anything else from here? The logic can be, why router is sending unicast message, second message as unicast. It can be your question. Guys, let's say I have one router over here, R1. This router is connected with one switch, and here I have two router. Router 1 have sent one update message on multicast address 224.0.0.10. This router have give acknowledgement, but this router have not sent acknowledgement. So now router need to send the update message to this router only, right? If this router will send again on multicast address, so unnecessary this router will also receive, yes or no? So that's why second message will be always unicast. So this type of question you guys should ask.
So like in on serial link, it always going to be a unicast. So what timer it going to be used? First time it use SRT or RTO. Which timer it follow on serial link, sir? Because on
On serial link also it will follow SRTT time. Now first it will send the null update.
okay.
Let's say it is getting acknowledgement within 20 millisecond. So that timer will become what? SRTT. So now whenever router will send update message, it will expect acknowledgement in 20 millisecond. Okay. Let's say here we have one router. Here we have one router. Here I have one router. And I have one switch. I don't want to use access control list before discussing ACL. That's why, I think I should discuss ACL before routing. I'm going to configure eigrp. Router eigrp 10 network 192.168.10.0 wildcard mask 0.0.255. Done. On router number 2 and 3 also I am going to configure it. Router eigrp 10 network 192.168.1.0 0.0.255, and on router number 1 also, let's say router eigrp 10 network 192.168.1.0 255.255, sorry, wildcard mask 0.0.0.255. So IP eigrp neighbor. Done. We have only this neighbor. Ping 192.168.1.3. I have not configured eigrp on router 3. Router 3 eigrp is okay. Not 10, it's 1. Okay. Now what I am going to do, I am going to apply access control list over here, so that this router will not receive update message of router 1. So router 1, when router 1 will see the update message, it will send the update message to router 2 and router 3. Router 3 will not give acknowledgement. Yes or no? If you want to see, I can show you. See, I will capture this link. And before that, I need to increase the hold on time. Otherwise, neighborship bill goes down, right? So let me take you to R1 config T interface F0/0 IP eigrp IP. What is the command to change hello time? IP hello interval for eigrp 10, and let's say hello time is hello time, not hold on time. I need to change. Hold on time eigrp 10, and let's say it is this one. Copy this command and let me paste this command on router 3 also. Interface F0/0, this one. Done. Now I am going to apply access control list on F0/0. Access IP access group 101 and direction in. I will apply it in direction. Before applying, just I am going to create one loopback on router number 1. Interface loopback 1 and IP address is 10.1.1.1 255.255.255.0. So once I will advertise this network in eigrp, router 1 will send one update message. Yes, before that I am going to apply this access control list over here, and I am going to say router eigrp 10 and network 10.1.1.0. See, it have sent the update message, and this is different capturing. Here it is. See brother, from here router 1 have sent the update message. Yes, after that this update message on what address? On multicast address. Then router 2 have generated the acknowledgement 192.168. This is not the actual message. This is, I think, update message. Let me check inside the update message which network it is sharing. Yes, this network. Yes or no? And on router number 1, so IP eigrp neighbor. Q count is Q count for this neighbor is 1 increased. And here see, router 2 have sent the acknowledgement. Yes, very good. Router 2 192.168.1.2, but router 3 have not sent the acknowledgement. So it started sending unicast update message. See, source is 1.1, destination is 1.3. It is sending the unicast update message 16 times. If you will count, so it will send 16 time update message to router 1 to router 3, and after that it will break the neighborship. So IP eigrp neighbor. See, hold on time is, we have very large hold on time, but before hold on time it will not wait for hold on time, it will discard the neighborship. I think it is receiving the hello message and again it is forming. Let me check one thing. Still it is sending the unicast message. You know what is happening, again and again it is breaking the neighborship, and again neighborship is forming between router 1 and router 3. So why router 3 is not dropping the traffic? So IP eigrp neighbor. Oh, this neighbor hold on time with this one. Okay, no problem. It is forming neighborship. Again you can see the log message over here. Debug. Okay, leave debug. If whenever you are configuring eigrp or troubleshooting eigrp, Q count is not 0, that means there is some problem. We have wrong output as well. In the sometime we will have wrong output. It is sending 16 time update message, after that it is breaking neighbor, and then again it is forming the neighbor. So that's why you are able to see that this timer is resetting. See, 98, 96, 99. After 5 seconds it is receiving the hello message, and router number 3 is also receiving the hello message. See, timer is resetting. Okay, it is not receiving hello message. Once this timer will become 0, it will break the neighborship. So access list. Okay. Fine guys, we have lots of concept in eigrp, don't worry, you will understand everything. So tomorrow we will discuss first about the rest 2 messages, that is query and reply. Today we have discussed hello message and update message. In update message we have discussed 2 types of update message, multicast and unicast. And